Okay, this is a test video for ABOs. Here's all my supplies. This is the standard blood bank timer. Here's my tube rack. And here are all of my blood bank reagents. So for most ABOs, we have anti-A, anti-B. It's not used very commonly for most blood types, but here at the reference lab, we sometimes use anti-A, B to help pick up subgroups. We also have anti-D, and then we have a pre-made Rh control. This is made by Immucor called gamma clone control. So those are all of our antiseras. They help us detect the patient's forward type. So we're testing the antisera with the patient's red blood cells. Here we have our reagent red cells. So this is about the color that we want to see. This will also help you determine a good 3 to 5% solution. So our A1 cells and our B cells, we will be testing with the patient's plasma to get the patient's back type of their blood type. So here at the Red Cross, we use a size of test tubes called 12 by 75. They are slightly larger than the 10 by 75 tubes that you'll use in class. So there's many ways that you can label your test tubes, but make sure that you label them based on a way that you can follow them.
Cool stuff, man.
Yep, that's Francie. That's my coworker. She approves.
Sorry.
You're fine. It's just a test. All right, so like I said before, you need to label your test tube so that you can follow it in case you get interrupted by a phone call or a question from somebody, that you can go back to what you were doing and follow along. So I like to label mine out. So I use the alpha symbol for anti-A, anti-B, anti-D. We always run a D control here when we do blood types at the Red Cross. We're checking for spontaneous agglutination. And then for my back type, I put A1C and BC for A1 cells and B cells. So this is what my test tubes look like. So that's anti-A, anti-B, anti-D, my D control, my A1 cells plus the patient's plasma, and then B cells. Alright, so when you're adding blood bank reagents, you should look and check the package insert for most of these. Most manufactured reagents only require 1 drop of reagent to be added to the test tube, and that goes for most antiseras. So anti-A, I'll be adding 1 drop to the anti-A tube. They color code these to make it easier for you to keep track of what tube you're reading. So anti-A will always be blue. Anti-B is almost always yellow. You'll notice that when I'm dropping this, I drop at an angle, not straight up and down, but at an angle. Okay, so another thing that you want to get used to when you're doing this is always check what tube you're about to add it to with what you're actually going to drop in there. So with my anti-D tube, I'm going to double check that I'm adding anti-D. So quick check for me. Okay, 1 drop into my anti-D tube. Here's my gamma clone control, my Rh control. All right. Now, we always want to add our antisera first, because as you're looking at these tubes, it's hard to tell, other than the anti-A and anti-B, what's been added to that tube. The same goes for patient plasma. We always want to add our patient plasma first to the tube to make sure that it's been added. If we were to add our red cells, it would be hard to know if we had already added our patient plasma. One other trick that you can do if you're not sure is you can pick up your rack and shake it. You can see that I've added something in the front 4 tubes, but not in the back 2 tubes. Alright, so this is my patient sample. Most of the plasma has been taken off for other testing, so I'm mostly going to be concerned with the red cells here. This was a donor for the Red Cross. So to make a 3 to 5% suspension, again, you can use your reagent red cells as a guide. They're closer to 5%. But you always want to label your aliquot tubes with at least 2 patient identifiers. Since this is a donor and there's only a unit number, basically, I'm just going to write 3 to 5%, and I'll put the last several digits of the DIN number. And then here at the Red Cross, they require you to write your initials and the date that the aliquot was made. Today is the 31st. Okay, so once you get practice with making 3 to 5% suspensions, this will come a lot easier to you. But if you have your transfer pipette here, if you really only go up to maybe like right there on the transfer pipette, you won't add too many cells. So going into the tube, I'm going to add about that many red cells and add 1 drop to my tube. Then you're going to fill the rest with blood bank saline. And a 12 by 75, that's to about that level or so. You can see that a lot of the red cells are still stuck down at the bottom. So we'll grab a transfer pipette and mix that up. Okay, everything's in solution. It's a little light of a suspension. So if you ever add too much saline, you can either go back and add more red cells or spin the whole thing down and pull off some of the plasma. Okay, so you can compare it to the reagent red cells. It's always going to be a little bit lighter. Again, reagent red cells about 5%, and we want our patient red cells to be closer to a 3 to 5%. So now that we've added our antisera to the front type tubes, so anti-A, anti-B, anti-D, and D control, we're going to add patient plasma to the back type tubes. So because we were doing testing on this patient earlier, plasma has already been aliquoted off. So with patient plasma, we are always going to add 2 drops for our blood types. So 2 drops into the A1 cell tube and 2 drops into the B cell tube. Okay, now quick double check. Looks like there's liquid and everything. We can add our red cells now. So I'll add my patient cells. 1 drop. Now I'm going to add reagent red cells. So 1 drop. And again, you always want to make sure and double check what you want to add is the correct thing. So B cells into my B cell tube. Okay. Everything has been added. So we now have our front type and then our back type. We're going to spin this down for 15 to 20 seconds, depending on what centrifuge you use, and we'll go from there. So because we don't really have dedicated centrifuges, we use cell washers as centrifuges. This is my cell washer tube rack, and but it will balance just like a regular centrifuge. So we have a total of 6 tubes, so you can do that a couple of different ways. I just like to do 3 and 3. Alright, so I have 3, opposite of 3, with a space of 3 in between each side. And, should be balanced. So I'm going to put this into the cell washer, which doubles as a centrifuge. Close it. These are the same ones that we have in the classroom. So to use it as a centrifuge, you'll choose either high or low. We always go with high, because we want to pack these cells down into a button so that we can read it. I'm going to push high, and it's going to tell me it's going to spin for 20 seconds, which is what we want, and then you push start. So that sound you hear is the little centrifuge rotor head spinning like this, and it goes around in a circle. It's mixing that sample for you. Okay, so here is the tube after I have pulled it out of the centrifuge. All of the cells have been spun down into a nice tight button at the bottom of the tube. So this is my anti-A tube. So I'm going to shake it and then read it. So you start with a sort of gentle shake and kind of rock it back and forth. And what you're looking for is at the bottom, that red cell button, how it shakes off. So either you get that swirling tail, like this sample is doing, or you'll get chunks coming off of that button. So you want to keep shaking until that red cell button is completely dislodged. Okay? And you want to also tilt your tube back and forth so that you can see any weaker reactions or small agglutinates. I don't see any at all. So I would call this reaction negative with anti-A. Okay, here's my anti-B. I can tell because the antisera is yellow. So I like to rotate my button until I can see it in the mirror, just like that. So I'm going to do a gentle shake. You can already see that the entire cell button has been dislodged and it's floating in the rest of that antisera. So that is a very strong 4+ reaction. This is my anti-D tube. Again, we're going to look at that cell button, do a gentle shake. You can see how it's starting to swirl off. But even though we might see some initial, what looks like agglutination, you're still looking at how the entire button is dislodging. And this person appears to be D negative. So this sample, this reaction in this tube is negative. Negative with anti-D. no agglutination seen. This is my D control. So again, I'm going to shake that out, and we should not see any agglutination in this sample, which we don't. So we can still see that button slowly swirling off, which is a negative. Okay. This is my A1 cells tube. So I'm going to do a gentle shake. And that is a very strong reaction as well. I would call that a 4+ reaction. And this is my B cell tube. So again, start with a gentle shake, start rocking back and forth, and you're reading how the cells are coming off of that button. This is swirling. It takes a lot longer to get the entire red cell button to dislodge, which is another indication that this is a negative reaction. So this person is negative with their B cells. Alright, so looking at it all together, my front type, anti-A, anti-B, anti-D. We have a negative reaction with anti-A, a very strong reaction with anti-B, and a negative reaction with anti-D. So remember, this is the patient's red cells with antisera. So we are testing to see which antigens are on the patient's red cells. So according to these results, this patient would have the B antigen. They do not have the D antigen or the A antigen. And again, our D control was negative, so there's not any sort of spontaneous agglutination occurring. And then our back type, or reverse type, with our A1 cells, very strong reaction. And get a good image there. And then a negative reaction with the B cells. There we go. So A1 cells, 4+, B cells, totally negative. Those red cells are completely dispersed into the saline. So, what does the back type measure? It's measuring the antibodies present in the patient's plasma. So we used reagent red cells. So it's kind of like the opposite. So since we have a 4+ reaction with our A1 cells, that would indicate that the patient has anti-A in their plasma. Since they did not react with the B cells, they do not have anti-B. So this patient's blood type written out would look like this. So just looking at their forward type, the forward type is B negative, Rh negative. And their back type also supports that. So B people have anti-A, which makes sense because they reacted with the A cells. So this patient is a B negative.